Welcome to the session on data visualization. You've done everything you need to do for a marketing research project by now. Identified the problem, came up with the research design, gathered data, analyzed it. But your job is not quite done. By far, the most important thing in a marketing research process is to convey the results to people who are going to make a difference. It isn't sufficient to put together a regression model. You need to convey the results of the regression to senior management, the ones who've given you the task to begin with, or the ones you want to persuade to take some sort of action. In this session, I'm going to talk about data visualization, a chart-driven way to communicate your research results. There are many research reports. People write long reports that never get read. On the other hand, it is those captivating images that draw attention, the ones that motivate action. Those are the ones that get people thinking, they get conversation started. And often that's where it all stops. Many people don't even go past the cover page. A captivating chart in The Economist magazine might make people want to buy the magazine. That's all they will probably ever read. For better or worse, data visualization is what makes a big difference in terms of your research project. So with the next couple of minutes, I'm going to talk to you a little bit about data visualization. In a later video, I'll talk to you about how you can construct these compelling charts using a software called Tableau. Let's get started. Data visualization is the use of visual representations to explore, make sense of, and communicate data, according to Stephen Few. It's a practice of graphically representing data to help people see and understand patterns, insights, and other discoveries hidden inside your information according to linear drawing. In general, when you visualize data, you communicate information in a very natural way that is clear, attention-grabbing, memorable, and persuasive. Let's dig in a bit deeper. Take a look at these numbers on your screen. You can pause the video and try answering the question. How many threes do you see? If you pause the video and hit play again now, let's see the answer. Before we find the answer, let's answer that question again. How many threes do you see now? Again, pause the video, answer the question, then hit play again. All right, welcome back. The point about that graph is not about the number of threes there are. The point was about being able to highlight information. You can see that as soon as we use something like color, other possible aesthetics are size, shape, outlining, boundary, enclosure, so on and so forth. They help highlight information. By a simple visualization, simple visual trick, like changing the color of the number 3, made it easier to spot amongst many other numbers. It is almost natural for us to be able to spot different colors. In fact, visualizing things comes naturally to us. Everybody is predominantly visual. You often hear about people saying that they're not so mathematical, but they don't get numbers, that they're a visual person. It turns out even the smartest mathematicians in the world are basically visual people, because that's sort of part of our DNA. We are more likely to perceive things that are visual than things that are written or numerical. And maybe this has evolutionary roots. If you imagine us being cavemen or Neanderthals, living our lives in forests and living in caves, dodging rough weather and protecting ourselves from wild animals, you can imagine the most important thing to keep us alive in those forests thousands and thousands of years ago was probably our sense of vision, being able to look at things and know how to respond right away. Not to be too analytical, but to know that if a lion is rushing at you, you need to run and get away from there and take cover. Visualizing things is natural. It's also clear. Take a look at this table that puts together results of a survey on time spent on various activities by gender and day of week. Now think of the question, how does a weekday for a man differ from that of a woman? Again, you can pause the video, find the answer to the question before hitting play again. I'm sure you probably spent a couple of minutes going through this entire table, identifying from activity by activity, looking at the numbers for men, then for women, for weekdays and weekends and so on, and coming up with a profile or persona of the activities of men and those of women. Maybe you found they go counter to stereotypes, or maybe they conform to stereotypes, who knows? The answer to that question, however, may have been more easily answered with this. Here's the same information expressed visually or graphically. Here we have the average hour spent in each activity, broken down and categorized, identified here for men and women. I've made use of colors here that I thought, or here the Bureau of Labor Statistics made a conscious attempt to pick colors that may not be viewed as being sexist, yet are distinct enough to identify men or distinguish men from women. You can tell here, for example, that there are small differences in certain areas like sleep or personal care, but there are bigger differences in maybe household activities and work-related activities amongst men and women. Let's go on and take a look at another data set here. This is a small sample of a large data set that has sales figures by week. Now, I'm sure if you look carefully enough, you may be able to spot some sort of a trend amongst this data, a trend for sales figures. Of course, you'd have to probably sort all the numbers by date first, and then perhaps analyze or somehow summarize your data by month or year to look for some trends for sales. Now let's look at a visual of this exact same quantitative information. Here it is. Faced with the question of whether there is seasonality in sales, looking at the graph makes it really easy to understand and realize that there is clear evidence of seasonality here. Clearly, there's a peak in Q4 from one year to another for this 4-year period. And that underscores again the importance of, or the fact that once visualized, data is a lot more clear than in a spreadsheet format. Here's yet another example of the same point. The goal here is to compare pattern of sales across domestic and international customers. If you carefully look through these numbers for the months January to December, for domestic and international, maybe you'll spot a trend, maybe you'll spot aberrations, maybe you'll see outliers, or maybe you'll see seasonality. But I assure you, it's going to be more difficult to look for those trends here than it would be in a graph. Hopefully you agree with me. The domestic sales clearly showed evidence of seasonality. In international sales, we don't see any seasonal pattern, but we do see a lighter than usual, lighter compared to other months, August. Visualizations help us to then spot trends and identify patterns, easily and rapidly compare values. John Tukey said this many years ago. A picture is not merely 1,000 words. It is much more likely to be scrutinized than words are to be read. This is just as true when he said it back then, 50 or so years ago, as it is now. In fact, research has shown us that not only is our graphs attention grabbing, they're also memorable. Research has shown that visualizations are faster to process, easier to understand. They draw attention more, and they have a far greater influence than words and text. Most importantly, they're also memorable. They're remembered and recalled much better than our numbers. Moving along, charts are also persuasive. They're also likely to have more of an impact than raw numbers. Here's a personal story on this subject. Many years ago, while I was working for a company called UPS in India. I was entrusted by my boss to put together sales forecasts for the company. The company as such manages business in India, by breaking the country into areas and regions into areas, and areas into territories. So I was entrusted with putting together a sales forecast for 250 territories, combined into areas and those into regions in the national, for the next 8 quarters. So 2 years, 8 quarters. Being analytical from a very young age, I imagined the smart way to go about this would be to look to the past, because there's no better tell of the future than the past. Using some sort of a smoothing approach, I tried to replicate the trends going into the future. And turns out I got I put together a spreadsheet full of numbers. Given the large number of territories involved, the spreadsheet looked pretty large. Imagine there are 250 territories that we have sales data for, and if you're going to forecast them out 8 quarters, you're going to have 250 times 8 sales numbers. And then, of course, there'd be similar numbers for areas and regions and national. So what I gave my boss looked something like this. These are, of course, not the same numbers. I can't share those with you. Those are confidential. But this is sort of like in spirit what came out of it all. Right? One gigantic spreadsheet full of numbers. And I had, a boss that looked like this when he got these numbers. He was really into the data I shared with him, very focused, very interested, or he seemed like interested. And I knew he was interested and cared about it because he gave me a pat on the back and he told me that my work was quite exceptional. I went back to my desk feeling pretty good about myself, only to find out that, a few weeks later, that I'm being invited back to his office to do sales forecasts. Obviously, surprised, I asked him if he hadn't seen the forecasts I shared with him. And he said he had seen those and that was really good work, but now we're going to do forecasts in his office. And so he sat for the next couple of hours with me, and in his office, I sat in front of him, and he literally pulled numbers out of the air and plugged them into a spreadsheet to construct forecasts. I was, of course, horrified by the process, and I went on for many years telling people the story about how bosses like this who rely on gut feel and judgment are probably going to fall on their face someday when they realize that humans are inherently biased beings, and how managers ought to be more quantitatively and analytically driven. But looking back now, I still believe that my boss would have been better off being more analytically minded. But I realized my own folly, though. Looking back, I realized that my mistake was I gave him a spreadsheet full of numbers. I gave him too many numbers. I gave him too much to chew on. Stuff that was not pleasing or good and easy on the eye. And maybe at the time, he was too embarrassed to accept that I had overwhelmed him with information. Maybe if I had, instead of giving him a spreadsheet full of numbers, gone with something more visual, he may have appreciated it. So let's say, what if I had, instead of giving him a spreadsheet full of numbers, told him, boss, let me tell you a story. What if I had gone to him with one big picture? What if I had given him the onion? Give him national figures. And as he asked me more questions, what if I then peeled layers of the onion? What if he asked me, let's say, okay, here's national. And he sees the graph and identifies the thinking behind the trend analysis. The fact that I'm trying to replicate previous trends into the future would be apparent from this graph. And then what if he asked me to break the numbers down, and I broke it down? So I allowed him to then peel layers of the onion, thus only giving him as much as he needs, not overwhelming him. Quite likely, he would have been happier. Maybe he would have been more pleased. Maybe, just maybe, he would have been more likely to accept my feedback, my work, and it would have been probably more welcome if I presented in this form than giving him a raw spreadsheet full of numbers. At the end of the day, his actions would, of course, have been based on the numbers, but the story is important. The story is important in making in breaking through to your audience. And that's exactly what we'll be doing here. We'll be focusing a lot on being able to tell stories, effective stories that are backed by data. So chart-driven, graph-driven stories that will do a really good job of communicating effectively to those who we want to tell a story to. But before we go there, the idea here is not to replace traditional analysis. In fact, what I would say is that sometimes visualizations may complement traditional analysis. A good visual may at times help you see things that traditional analysis may not even be able to spot. Think about spotting patterns and trends. Clearly, you can do outlier analysis, but spotting those patterns and trends and anomalies is a lot easier in a graphical form than it is using outlier analysis or pattern analysis. Take, for example, this famous data set. It's a fictitious data set called Anscombe's quartet. This one's taken from Wikipedia. Given here are 4 sets of numbers. You have XY columns repeating 4 times. Repeating maybe the wrong choice of words here. What I meant to say here is that you've got X and Y 4 times over, but the contents of X and Y are different. You'll see that in the first quartet, we have the Y's have numbers like 8.04, 6.95, 7.58. And the second one has numbers 9.1, 8.14, 8.74, and so on and so forth. Bottom line, you've got 4 sets of numbers out here. Now, if you just look at these numbers, well, they all look different. Now, we can use summary statistics or descriptive summaries to examine these numbers. And it turns out if you were to look at the average of any X column, you'd find out the number is identical. Same for all the Y columns. All the Y columns are the same exact mean. All the Y columns also share the same standard deviation. Now, what is really curious about this is that if you were to map X to Y, you'd find out they all 4 quartets have the exact same correlation between X and Y. If you would draw a regression linking Y to X, you'd find out they're all expressed by the same exact regression equation. So here it is. Traditional descriptive statistics and even regression would have told you all 4 data sets are identical, pretty much, up to 3 decimal places. Here's what we learned from plotting the data. If you look at this picture, I'm sure you'd be convinced that Anscombe's quartet consists of 4 very different sets of numbers. In the first one, the dots are nicely along the blue line. The second one indicates a curvilinear relationship. The third one in the bottom left-hand corner panel shows the role of an outlier, an influential outlier. And you've got in the fourth one, the bottom right-hand corner one, a single observation that's holding the graph or the regression line. So it makes sense to think about visualizations not as a competing methodology here, rather as shining more light onto the results of traditional analysis. Now, in today's world, we're seeing charts are everywhere. They're so ubiquitous. When you think about dashboard maps that warn drivers of traffic with thick red lines, or weather apps that have icons and trend lines and so on. Most people use a fitness app like a Strava that tells them a bit more about their steps in a very nice visual, graphical way. Even boring utility companies nowadays have used graphs to compare, for example, energy usage of a person with that of everybody else in their area. Social media, is full of data visualization being passed around. And then you see sports broadcasts where they show, for example, the ESPN yellow line and so on. In baseball, again, showing the trajectory of a ball, and so on. So there are, it seems like data visualizations are everywhere around us, right? We're seeing them in professional forms, we're seeing them in our personal forms. On the left is a sea swim I engaged in last year. On the right is my heart rate during the same period. So the bottom line here is we got these visuals showing us where you're going, how many steps you're doing. So even your personal data is being graphed out by apps you use. So visualizations are ubiquitous. They're everywhere, right? And why wouldn't they? Because they're easier. They're just so easy to make. Software makes the process of making visualizations really easy, right? So even somebody with no computer science background can make really, really compelling, really good visualizations. Take, for instance, here is a kind of scrappy looking graph from a couple of years ago. And it would have probably taken a long time to build this one, whoever put in the effort to build this one. And there's this now. So what we have now is so dramatically different, so much more professional, and made in a fraction of the time that the earlier one took from back then. Okay. The fact that there are so many graphs out there, so many charts out there, so ubiquitous, raises the bar, which means it's not okay to just build a simple bar chart. Your bar charts need to be amped up. They need to be at a very high level, high standard to really, really grab attention. Here are some links that again talk a lot about some of the visual revolution, and I encourage you to take a look at these, from looking at crime to the Big Mac index to so on, all these different examples of some really, really compelling charts that sort of show you the evidence of this visual revolution I'm talking about here. We have, of course, a number of software that enable this process, from Tableau to Click to R, Python packages, and so on, that can make these really, really, really well. One way of thinking about the software that enable good data visualizations is to categorize them as code-based and menu-based. There are ones that require to write computer code to make the visualizations, like working off Python library, an R library, JavaScript library, or ones that involve menus that a lot of folks are more conversant with, like the ones on maybe Tableau or Power BI. Okay, so we're going to be focusing here in the next video on Tableau, one of the software that is menu driven and has a number of benefits in for making effective charts. You can make the next video on Tableau.